Half the students wouldn't even bother trying this question, so let's solve it. Now at first glance, this looks like a functions question because it says that f of x equals 5x plus 3 and g of x equals ax plus b. But if we read the rest of the question, it's actually a hidden simultaneous equation. The reason why I know this is because it asks us to find the values of a and b, and at GCSE the only way to do this is through simultaneous equations. The first equation is really easy to find. All I have to do is substitute 3 into the equation g of x and make it equal to 20, as it says so in the question. So when I do this, I get 3a plus b equals 20. Now for the second simultaneous equation, we need to find the inverse function of 33 and the function g of 1, because the question tells us that those two are equal to each other. First, I'm going to find the inverse function of f before substituting the 33 into it. I do this by calling the equation that we have y and rearranging it to make x the subject. Then I replace the y with the x and call that our inverse function. Now that I've done this, I'm substituting 33 into the inverse function to give me 6. G of 1 is really easy to find. All I have to do is substitute the 1 into the g function to give me a plus b. Now because the question told us that the inverse f of 33 equals g of 1, we can say that 6 equals a plus b, and that becomes our second simultaneous equation that we are going to have to solve. Our final step of this problem is to solve the simultaneous equation, so I'm going to write one on top of the other and then solve it. Because in both of these equations there is a b, if I subtract one equation from the other, I will be able to eliminate the b, because b minus b equals 0. Doing that, I get 2a equals 14, so that means that a is 7. My next step is to substitute the a back into one of the equations. It doesn't matter which one you choose to do. I chose the second one in order to get b equals minus 1. And that's our two answers. So we've got a equals 7 and b equals minus 1. This question is worth 5 marks, and now you know how to get all 5.